World Spaceflight News Special Report.
This team has really persevered through many challenges, and from the outset we spoke about how this was a deliberate stress test of our deep space human transportation system. And we've been up front with you about how this was going to be a challenging mission. We set some bold priorities. Priority 1, demonstrate the vehicle at lunar reentry conditions. We successfully demonstrated that today. Priority 2, demonstrate the vehicle in the flight environment. We've successfully demonstrated that over the course of a 26-day test flight. Priority 3 is currently in progress. The vehicle is powered down and it's in the Pacific Ocean. And as Melissa Jones will elaborate, the vehicle recovery and retrieval is in progress, and we expect to complete that here in the next couple of hours. And then priority 4, our bonus objectives, sharing the mission with each and every one of you, public outreach, sharing remarkable images, completing science and technology demonstrations. We've completed that, plus some bonus objectives. So this is what mission success looks like, folks. This was a challenging mission, and this is what mission success looks like. One of our forefathers in the Apollo program, Hugh Dryden, spoke about the purpose of flight testing. And he said it was to separate the real from the imagined and the known from the unknown. And I don't think any one of us could have imagined the mission this successful, but we had a very successful flight test. We now have a foundational deep space transportation system, and while we haven't looked at all the data that we've acquired, we will do that over the coming days and weeks and fully understand and appreciate the margins that are there. I'll just say in closure, we're sharing a historic day with the Apollo 17 mission, and Gene Cernan left a plaque on the surface of the moon, and I'll paraphrase it here. May the spirit and the peace in which we executed this mission continue forward for all mankind. This mission was a peaceful mission using partnerships from across industry with our international partners, with our science partners, and we're going to grow out from here. There are more complex and more challenging missions ahead, but we've got a foundational capability here. So with that, I'll pass it back to you, Jackie.
What a fantastic day for Orion and Artemis. Senator Director Weiss said we have a fantastic team. The Orion team would have been tremendously happy just getting the data, but this accomplishment that we've been able to do all through this 25.5-day mission has been so rewarding, and we've been able to get a lot of data. And I want to thank the teams today. They've worked really hard. Flight operations team has done a tremendous job operating our spacecraft. Our engineering team, our safety team, and our lead integration team has been tremendous in trying to not only just get the data down, but also looking at the data and adding additional objectives. I'll give you some highlights. We were able to be very successful in terms of our operating our systems in space, and our return has just been the same in terms of our success. We were able to hit 0.02 degrees within what we want to do for our flight path angle, and we landed within 2.1 nautical miles of our target landing site. Our requirement was 5.4 nautical miles, so tremendous success in terms of return. Of course, we demonstrated 6 skip entry capability. That went flawlessly as well, and we'll be looking forward to our heat shield data as we gather that and learn more about the heat shield performance when we get the capsule back. But overall, the mission has been tremendously successful. We've been able to accomplish over 122 of our flight test objectives that we had planned, and we added a bonus of 20 real-time flight test objectives as well. So great job by the team. Happy to look through the data even more, and we're ready to accomplish Artemis II going forward. So thank you.
Thanks, Howard. And now we have Emily Nelson.
This mission, this spacecraft and this team exceeded all expectations. I think we're all in unison on that. The spacecraft performed so well that we were able to start looking ahead at Artemis II and thinking through how else can we push the boundaries on this flight? What else can we learn? Where are there constraints that we can push on? Where are there opportunities for us to to improve on our products for the next flight. And so for the last 25.5 days, we've been every day looking ahead to the next flight to see how we can improve on where we are today so that we can fly a safe and successful mission with our astronauts next time around. The team in Mission Control will spend a number of months combing back through every experience that we've had in the last month and improving our products, figuring out what we could do better, figuring out what went well and we want to repeat. And meanwhile, in low Earth orbit, we will continue to develop the technologies that are going to make Artemis 2, 3, 4, and sub successful. We'll be installing another rollout solar array, which is the technology that we'll be using on Gateway. We'll be continuing to develop some of our more human systems inside of the space station. So our work has really just begun, and we're really looking forward to unpacking everything that we had to learn from this mission as we prepare for the next one.
Portland. It's a beautiful day to be on a ship. The Orion continues to perform nominally even post-splashdown. We just completed our open water hazard assessment of thrusters and RF radiation and all were within limits. Currently we're doing some underwater imagery to get some good pictures of the heat shield before we bring it into the ship, and sea states are looking good for well deck operations at this time. So we'll continue with our open water operations. We're going to put a collar around the capsule and the ship will approach and we'll attach lines and bring Orion into the ship. And at this time, everything's picture perfect.
The biggest surprise for me was a positive one, and it was simply that the first time flight of a brand new rocket, a brand new spacecraft, first time operations went as smoothly as it did. And I think that's a testament to the level of preparation, the quality of workmanship, just the overall level of test and integration and just effort put into getting this mission ready to fly. In terms of bringing the core stage engine section to the Kennedy Space Center, you know, that's an efficiency that we're looking at, and shipping it and then assembling it vertically is something that we've been prepared to do, and the infrastructure at the Kennedy Space Center affords us an opportunity to do that, as opposed to a horizontal integration at Michoud Assembly Facility near New Orleans. The work at Michoud is still going to keep going on. We still need to build tanks. We still need to build the large components, and we'll ship the bulk of the core stage, minus the engine section, to the Cape, and then mate it at the Cape once it gets there. It actually affords us some efficiency by splitting the workforce rather than having competing workforce on the competing work instruction priorities on the shop floor at Michoud. So I think it's a good thing, and it again is something that we've learned how to integrate one of the more complex systems on the core stage. I don't know, Jim, you've been in some of those conversations as well, and if you have anything to add on the core stage.
At Michoud, we have to construct a clean tent around the engine section when we do a lot of the installations or take things off to test. So at Kennedy, we actually, and so you take that up and down, it adds time. At Kennedy, we don't have to do that. We'll process in the space station processing facility. So we're hopeful that the engine section, which is incredibly complex, will improve in its schedule time. And then the work Mike mentioned about workforce, you know, we're starting to ramp up the exploration upper stage work at Michoud also. So we have a lot of work for those folks to do on stuff out through Artemis 4, and we're already starting weld confidence articles and structural articles on the exploration upper stage. So it helps us with efficiency and hopefully getting to that 1-year cadence as fast as we can.
The center of gravity and the center of lift are slightly offset. And the way that you control the lift vector is you rotate one about the other, and you can control which direction the vehicle is lifting up, lifting down. So those were purposeful rolls. I'm familiar and recall seeing some of the rolls when we had a signal between the two blackouts, and that was per the plan. And the blackouts were planned. We knew that those were coming as well. Anyway, in terms of unexpected items during reentry, I am not tracking any issues associated with the crew and service module separation, the reorientation of the spacecraft into the entry interface attitude to get aerodynamic capture, the entire skip profile. We did have 2 long blackouts. As I recall, they were each about 6 minutes in duration. We're going to have to look at the post-mission data recorders after we get the capsule back to shore to see if there was anything associated with it. But clearly, the vehicle flew the skip reentry just fine. The entry guidance system was spot on, as Howard indicated earlier, relative to the targeted landing site. We came down within eyesight of the recovery ship, and the vehicle was clean. Post-splashdown, all of the uprighting bags that protect in the event that the capsule flips over and needs to be automatically uprighted. All 5 of the bags inflated, and the vehicle was powered down successfully without any thruster leaks or hazards or anything along those lines. The team did leave, as part of one of our flight test objectives, leave the vehicle powered for 2 hours post-splashdown to gather thermal soakback data. As we came through the Earth's atmosphere, the vehicle saw temperatures outside of it at nearing 5,000 degrees Fahrenheit. That soaks back into the vehicle structure. We did collect data by having an extended power-up on the surface of the ocean. All that was fine. All the parachute deployments were fine. Probably the only thing that happened that we expected may happen and was likely was the forward bay cover sank in the ocean before we could recover it, and the parachutes sank before we could recover those. But we knew that was a possibility prior to flight. The fact that the parachute deployment sequence was all nominal really makes the retrieval of the parachutes kind of a moot point. So, in terms of anything unexpected, I would say no. In terms of the splashdown speed, I didn't get an exact speed, but we were targeting around 20 miles an hour, and that appeared to be about what the splashdown speed was.
The goal of going to Mars was first announced by President Obama, and it was thought at the time that it would be about 2033. But that was a dozen years ago. And now a more realistic goal is the end of the decade of the 2030s. But a lot of this will depend on the development of new technologies, the ability to sustain humans for a long period of time all the way. Part of that is going to be how fast we can get to humans, how fast we can get to Mars with a crew. And so we finally broke through with the Office of Management and Budget on nuclear thermal propulsion and nuclear electric propulsion research. I think that will be supportive by the Congress. New technologies to propel us there faster. And so that is why we set a target at the end of the decade of the 2030s to go to Mars. And then we're going beyond.
Yeah, I can answer the first question, and we'll have to let somebody else answer the thermal question. So this recovery is about 5.5 to 6 hours, and the reason for that is because the first 2 hours we had a powered-up flight test objective. We have about an hour and a half of imagery. So it's all about gathering data because it's a test flight. And then the last hour and a half to 2 hours will be installing a collar on it, attaching lines, and getting it in the well deck. So typically a recovery with crew on board that wasn't required for all of the flight test objective data that we're trying to get, and the flight test objectives would be significantly less than this and under 2 hours. But in this case, we're being very careful, trying to get all the data we can and trying to be very careful with the capsule when we bring it in and we set it down on the cradle.
It's a little early to say because, again, the peak heating period was coincident with the blackout, and we need to go look at the flight data recorders and see what the flight recorders told us or will tell us after we get that off the vehicle. But just a first blush look at the vehicle, obviously it survived the skip reentry. and there was some charring on the outside of the vehicle on the silicon oxide tape. We expected all that. We saw some hazing on the windows. We expected all that. So initial indications are very favorable, but there's more ahead of us in terms of exactly understanding what the reentry flight test told us. Is we have parallel recovery methods starting with crew on Artemis II. So we're preserving the option to do what they call open water extraction, which is literally open the hatch out on the water and get the crew out to a small boat and then transfer them to the recovery ship while the capsule is still in the water. The other method is literally just tow the capsule with the crew in it into the well deck, so that we're preserving both options to do that, and the recovery operations teams are prepared to do either of those.
I ask the question all the time of Jim Free, is the Starship meeting each of the benchmarks, the time schedules? And the answer comes back to me, yes, and in some cases, exceeding. I have been down to Boca Chica. It is a sight to behold, how they are putting those starships together and then the big booster. And their plan is that they're going to do a few test flights there. And once they have the confidence, they will bring the missions to the Cape. And until they get their permanent pad on the Cape, they will launch from the one that they are constructing right now that is in the outer perimeter of pad 39A. And you know, you're developing a new vehicle, a new rocket, and you can expect some delays, but thus far I'm told that they are on schedule. Their plan is to do an uncrewed landing in 23, late 23. That's a year from now. And then to do the crewed landing in late 24. So slips are always possible because it's a brand new system, but they have been quite impressive in what they have done with other systems.
We do have a number of dosimeters on board the spacecraft, both active and passive. There's also one bioexperiment payload that is on board that it contains a number of organisms, yeast and fungus and some other organisms that serve as basically an analog to help us understand radiation exposure. So we've got the bioexperiment samples in the cockpit of Orion. We've got the Mare mannequin torsos that one had a radiation vest on, one did not, and we'll get baseline data from that. And then there are other dosimeters in the cabin. So those will be removed as soon as we can once we get the vehicle back to San Diego, simply to basically stop the clock on those. And it makes it more difficult in terms of understanding what the results are the longer that they're sitting here on Earth, and there is some background radiation, there is some background decay in the experiments themselves. So that will be done to stop the clock, but none of those I would say are kind of high priority in terms of the overall processing of the vehicle. We just know we're going to get those off the vehicle, and there's a plan to do that.